Right now, inside the world's top AI labs, something strange is happening. The AI has started helping to build the next AI. At Anthropic, the model called Claude now writes more than 80% of the company's own code. Let that sink in. The AI is writing the AI. And here is the part that should make you sit up. Anthropic and OpenAI, fierce rivals who agree on almost nothing, just published the same warning at the same time about the same thing: machines that can improve themselves. By the end of this video, you will understand exactly how an AI teaches itself, how close we really are, and why the people building it are the ones sounding the alarm. Chapter 1. The Loop. Start with the idea, because it is deceptively simple. It is called recursive self-improvement, and the loop goes like this. Humans use AI to help build a better AI. That better AI is then even more helpful at building the next one, which builds the next one faster. Each turn of the wheel makes the tool that turns the wheel sharper. This is not a new idea. Back in 1965, a mathematician named I.J. Good imagined what he called an intelligence explosion, a machine smart enough to design smarter machines, running away from human control. For 60 years, it was science fiction. The reason people are suddenly nervous is that the first steps of that loop are no longer hypothetical. They are shipping in production. The researcher Andrej Karpathy described the modern version as a loop. A model generates data and solutions. Those get filtered for the good ones. The model trains on its own best work, and it comes back stronger. Do that once, and you get a better model. Do it again on that better model, and you have a process that compounds. The trillion-dollar question is whether that compounding has a ceiling or whether it just keeps going. But before we get to how fast, you need to understand something more basic. How does a machine teach itself anything at all? Chapter 2. How it teaches itself. Here is the engine, and it is the most important part of this whole story. For years, AI learned from us. It read human text, and humans graded its answers. That has a hard limit. There are only so many humans, and only so much text. So the labs found ways to take the human out of the loop. The first is self-play. This is how AlphaGo became superhuman at Go. It did not study human games. It played millions of games against a copy of itself, and each side pushed the other to get better. No human teacher required. The second is synthetic data. Instead of waiting for humans to write more training text, the model writes its own. It generates problems, solves them, and studies its own best solutions, effectively writing its own textbook. The third, and the real breakthrough, is verifiable rewards. For anything you can check automatically, you do not need a human grader at all. Did the code compile and pass its tests? Did the math proof check out? If yes, that is the reward signal. The machine can generate 1 million attempts and grade every one of them itself for free. And the fourth is AI feedback. A frontier model can now critique another model's answer for less than 1 cent. A human doing the same costs $1 or more, 100 times pricier and far slower. Put those together, and you have a system that can generate its own lessons, grade its own work, and improve, with almost no human in the loop. So how much of that is actually happening today? Chapter 3, Where we are. Let's start with hard numbers from Anthropic. In June of 2026, its research group published an essay with a blunt title, When AI Builds Itself. The headline stat is the one we opened with. More than 80% of the code landing in Anthropic's codebase is now written by Claude. Before the launch of Claude Code, in February of 2025, that number was in the low single digits. In barely over a year, it went from almost nothing to writing the overwhelming majority. And the tasks are getting bigger. Anthropic's Claude Opus went from handling software jobs that took about 4 minutes in 2024 to jobs that take a full 12 hours in 2026. Dario Amodei, Anthropic's chief executive, says coding agents are already speeding up their own development by 20 to 40%. But Anthropic is careful about the words. They call this assisted self-improvement, not the full thing. Claude does the bulk of the building, including on the very systems that train and evaluate Claude. But humans still make the big architectural calls, run the safety checks, and launch the training runs. The AI is the hands. Humans are still, for now, the brain. So what is everyone else doing? Chapter 4. OpenAI's play. Now look at OpenAI, and the picture gets even sharper, because they put dates on it. Back in December of 2025, OpenAI published a blog that did something unusual for a company in a race. It warned about its own goal. It called recursive self-improvement potentially dangerous and urged the industry to share information rather than sprint in secret. Then it laid out a roadmap. By September of 2026, OpenAI wants intern-level AI research agents, models that can genuinely assist its scientists. By 2028, it wants fully functional AI research agents, able to write the code, generate the training data, run the evaluations, and even red team the models for weaknesses. That is not a coding assistant. That is an automated version of the people who build the models. Sam Altman has said that by March of 2028, a significant portion of AI research at OpenAI could be done by AI, working alongside humans. Read those two roadmaps side by side, and the pattern is clear. The two biggest labs on Earth are both racing toward the same finish line, and both quietly warning that the finish line might be dangerous. Why the fear? Because of what happens when the loop closes. Chapter 5. The danger. Here is why serious people are genuinely worried. First, the research itself is exploding. 74% of all the academic papers ever written on recursive self-improvement were posted in 2026 alone, roughly 500 of them in a single 3-month stretch. The field is not creeping, it is accelerating. Second, the nightmare is not that the AI gets smart, it is that it gets smart without us watching. Think about the danger this way. If an AI designs and trains its successor, any flaw in its goals, any subtle misalignment, gets passed down and amplified in the next generation, like a photocopy of a photocopy, except each copy is more capable than the last. And if each turn of the loop is faster than the one before, human oversight, which moves at the speed of meetings and reviews, simply cannot keep up. That is why both Anthropic and OpenAI, companies whose entire business is building this technology, have said out loud that they would be willing to slow down, and that they want rules and coordination before the loop goes vertical. When the people with the most to gain start asking for breaks, it is worth paying attention. So where does that leave us? So hold 3 things together. 1. The loop is real. It is not a thought experiment anymore. An AI writing 80% of its maker's code is the loop running today. 2. The engine is self-teaching. Through self-play, synthetic data, and verifiable rewards, machines can now generate their own lessons and grade their own work, cutting humans out of the training loop step by step. 3. We are at assisted, not autonomous. For now, humans still hold the wheel on the decisions that matter: architecture, safety, and the training runs themselves. The real question was never whether AI would start improving AI. That has already begun. The question is how fast the loop tightens, whether it has a ceiling, and whether the people building it can keep their hands on the brakes, because the machine is already learning how to teach itself. If this made the biggest story in AI make sense, subscribe. We break down what these systems can really do, minus the hype. Next up, inside alignment. How you keep a self-improving AI pointed in the right direction. See you there.